Hello students, welcome to Aptdemy's live platform. Based on your feedback, in this class we will discuss about a coordinate geometry problem, ellipse problem you can say. So this is the problem. So let us see what the problem is. Let D be the perpendicular distance from the center of the ellipse x square by a square plus y square by b square equal to 1 to the tangent drawn at a point P on the ellipse. If F1 and F2 are the two foci of the ellipse, then show that Pf1 minus Pf2 whole square is equal to 4a square 1 minus b square by b square. So this is the ellipse. This is x-axis. This is y-axis. This is center, which is nothing but the origin of the coordinate system 0, 0. So, and there are two foci, two focus, one at F1 and another at F2. And F1's coordinate, you know, it is AE0. AE0, whereas F2's coordinate is minus AE0. And there are two directrices of the ellipse. This is x equal to a by e, one directrix. This is another directrix, x equal to minus a by e. Okay. And let P be a point P, and if you draw a tangent at P, if you draw a tangent to the ellipse at the point P, then what is said? D is the perpendicular distance from the center of the ellipse to the tangent drawn at point P. So this is D, while this angle is 90 degree. Okay, so T dash or T1, T2, you can say it is the tangent. Now let coordinates of T be A cos theta, B sin theta, because the equation of the ellipse is x square by a square plus y square by b square is equal to 1. And in the parametric form, I have taken the coordinate of P as a cos theta, b sin theta. So the equation of the tangent at P tangent ellipse drawn at is how much? X a cos theta by a square plus y b sin theta by b square is equal to 1. That we have already learned. X square by a square plus y square will be square equal to 1. And if a cos theta b sin theta is the point, then at the point P, the equation of the tangent is x a cos theta b square plus y b sin theta by d square equal to 1. So it is, or I can write x cos theta multiplied by b plus y sin theta multiplied by a equal to a, or x b cos theta plus y a sin theta minus ab is equal to 0. And therefore, what is the measure of d? Measure of d is mod minus AB. D is the perpendicular drawn from 0, 0 to this straight line, tangent directly. So tangent's equation is this much, and if I drop a perpendicular from 0, 0, then this equation distance D becomes mod minus AB divided by square root of B square cos square theta plus A square sin square theta. Or I can write b square is equal to a square b square divided by, this is a square b square divided by b square cos square theta plus a square sin square theta. Okay, so I can write like this. So let me keep it as it is. D square equal to a square b square. So d square, expression for d square is a square b square divided by b square cos square theta plus a square sin square theta. Okay, so this much I can remove. So you have taken the coordinates of point P as a cos theta, b sin theta, and you have drawn a tangent at P, and d is the distance from origin, perpendicular distance of the origin on to the tangent, and P's coordinate is a cos theta, b sin theta. Okay. Now, okay. Now, what is, this P point, PF1 plus PF2 is actually always 2A. But here I have to find PF1 minus PF2. So if I drop a perpendicular from P on this directrix and call this hook of perpendicular N1, and similarly from P drop a perpendicular on this directrix and call this N2. So PF1 by PN1 is E, and PF2 by PN2 is also E. Okay. Now PN1 is how much? PN1 is actually, PN1 you can say it is A by E minus A cos theta, because coordinate of Pn1 is actually a by b minus a cos theta, and Pn2 is a cos theta. Sorry, this is a by b plus a cos theta, I can say, and Pn2 is actually a by b minus a cos theta. Okay, so P's coordinate is a cos theta, b sin theta. So distance OP, this distance is actually a cos theta, because this is the x coordinate of P. So this distance Pn1 is actually a cos theta plus a by b, and this distance is again a by b. So this distance Pn2 is a by b minus a cos theta. Okay, so Pf1 is how much? Pf1 is a plus a e cos theta, and Pf2 is a minus a cos theta. Therefore, Pf1 plus Pf2 is 2a. That we know. Now, what about Pf1 minus Pf2? Pf1 minus Pf2, in this case, I can write 2ae cos theta. Okay, so 2ae cos theta. So Pf1 minus Pf2 whole square is 2ae cos theta whole square is 4a square e square cos square theta. Let us recall e square is 1 minus b square by a square. So it is a square minus b square by a square. Okay, and b square we have calculated like this. So b square is, I can write b square, I can write a square b square divided by b square cos square theta plus a square 1 minus cos square theta. So it is a square b square divided by a square plus a square minus b square cos square theta. I can write like this. Okay. Now here I can write this is 4a square into e square is a square minus b square. From there I can write a square minus b square by a square cos square theta. So 4 so what happens? From there I can write actually d square a square b square plus b square a square minus b square cos square theta is equal to a square b square. So What is this? Or I can write b square a square minus b square cos square theta. Simple calculation, which is basically a square b square minus b square. Okay, so a square minus b square cos square theta is equal to, this is how much? This is, you see, a square by b square, a square by b square. B square minus b square. So it is how much? So a square, 4a square minus b square cos square theta, a square minus b square cos square theta, I have found this much. So I can write this as 4 times a square minus b square cos square theta. I can write a square by b square minus b square. So it is, there is some sign issue somewhere. So it is 4a square minus b square by a square cos square theta. So 4 square minus b square cos square theta. So here what is happening is, this is a square is 1 minus b square by a square. So a square minus b square by a square. So b square is a square b square cos square theta, a square 1 minus cos square theta. So it is, there is actually b square minus a square cos square theta. So there will be a negative sign over there. So you see, note over there. A square b square by b square cos square theta plus a square 1 minus cos square theta. So a square minus b square cos square theta. Okay. So it is basically, let me remove this. Just I want to find out the expression for a square minus b square cos square theta. So see here, it is a square b square by b square cos square theta, a square 1 minus cos square theta. So it is a square minus b square cos square theta. So I can write from there, it is a square b square minus b square minus b square cos square theta is equal to a square b square. So if I divide by d square, so what is happening? I can write d square, a square minus b square cos square theta, a square minus b square cos square theta multiplied by d square is equal to a square b square minus a square b square. And therefore, a square minus b square cos square theta is equal to, if I take common, 1 minus b square by b square. Okay. So I can write from there So it is 4 a square minus b square cos square theta. I can write this as 4 times a square minus b square cos square theta is 4 a square 1 minus b square by b square. So pf1 minus pf2 whole square. So pf1 minus pf2 whole square is equal to 4a square 1 minus b square by b square. So this is the equation we are supposed to put. So this is good. Okay. So I hope you have understood the flow. You have to think of the geometry of the structure. An arbitrary point we have taken instead of x1, we have taken a cos theta, b sin theta. The arbitrary coordinate has been chosen in parametric form. And since this measure, if I call this point L, where measure is actually a cos theta. So Pn1 is actually a cos theta plus a by e, because this equation is x equal to a by e, and this equation, this directives equation is x equal to minus a by e, and therefore Pn2 is actually this much length is a by e minus a cos theta, and then I have done like this, just taken the difference, squared it, and from this expression, b is the this perpendicular distance from origin on the tangent, and just adjusting and manipulating we could obtain this expression. So it's a problem where concept of ellipse, geometrical concept of ellipse, you have to have the clear concept of geometrical configuration of ellipse, and then you can work out the problem. It was said in one IIT exam, 1 year question paper, this problem was selected. So if you understand this, I think you'll be able to handle similar type of problems. Many such problems are given in competitive exams. Okay, I think you have understood the concept. You have enjoyed the video. Thank you. Thank you very much.